Two square tiles of same size are stacked upon each other such that their centers coincide. But the top tile does not completely cover the bottom tile. If the length of the sides of the tiles is 1 unit, show that the area that is common between the two tiles is always greater than 3 by 4. So it's a beautiful question. And so we're saying that wherever you place the second tile, or whichever axis you place the second tile, as long as the centers are same, whichever way we rotate the tile on top, the common area is greater than 3/4. Right? Or this area, which is outside, less than 1/4. That's what we want to establish. Right? So area overlap greater than 3 by 4. One way of doing it is to say mark out this angle. This angle will be same as this, same as this, same as this, and then use some trigonometry, frame an equation, and maximize the area outside. Prove that it's still less than 1 by 4. Or you take this as x. This will be some other thing. Solve, but that's all. That is using some amount of calculus and some amount of fudging and trying to see the maximum. You can intuitively figure out or guess that when it is symmetrically placed is when this area will be maximum, and then calculate that chunk, specifically that area, and then see if it is greater than 1 by 4. Then we'll have to prove that what we feel intuitively is indeed the way it is. Fine. But we've asked this question for one specific reason, because it's a beautifully elegant method for establishing this. Fine. So we want to see that this is always greater than 3 by 4. I want to imagine something that is inside here, which will be inside any square that is placed. And so, or we can imagine this beautiful shape that is this circle. And so this circle is going to be inside any square. So first of all, let's say that wherever the second square is placed, whichever way it is rotated, it is going to contain the circle. Now think about the circle's area, and then we'll go back to the square again. This has side 1, area is 1, so side is 1. So the circle has a radius of 1 by 2. The diameter is 1, radius is 1 by 2. Right? Our area of the circle is pi r square, pi into 1 by 2 square, which is 1 by 4. Our area of the circle is pi by 4. Now that's it, we're done, because it's saying common area should be greater than 3 by 4. Pi by 4 is greater than 3 by 4. Or area of the circle is higher than 3/4 area of the square. Now if you take the overlap between these two squares, it definitely includes that circle. It includes these bits also. But it definitely includes the circle. If the circle itself accounts for more than 75%, which it does, because pi by 4 is greater than 3 by 4, then the two squares common area will definitely be more than 3/4. It's a beautiful way of saying, look, pi by 4 is greater than 3/4. Therefore, I can use and imagine the idea of a circle being placed inside. When I first saw this solution, obviously I didn't think of putting a circle inside. I saw the solution somewhere. Initially I was surprised. How do you prove that the circle is always inside the square, no matter where you turn the circle? Fine, so think about this. This is a square that goes around the circle. Don't think of it as a circle being placed inside the square. The square goes around this circle. If the diameter of the circle is equal to the side of the square, it's possible. Or any place you place the square, you will always find that the circle is going to be inside there. A circle of diameter 1 unit, a square with the same center of side 1 unit, it will exactly circumscribe it. I had to think about it the other way to be very sure of it. When we have drawn it such that the circle is sitting inside both of these squares beautifully, I was like, why will this always happen? It will always happen, because the circle of diameter 1 placed inside a square of side 1, it has to happen. It has to perfectly be, one is perfectly inscribed inside the other, or the square perfectly circumscribes the circle. Beautiful question. Just putting a circle in between and introducing the idea of pi r square just simplifies life straight away.